Now let's run the regression in Excel to see if we can figure out the beta. And so what I'm starting with is the prices for the S&P 500, and I've chosen McDonald's. And we're going to do 60 months of data, 5 years. So 60 months of data returns require 61 months of prices. So I have prices starting in July of 2015. This is the end of July 2015 through the end of July 2020. Now I'm doing this before the end of August. Since August hasn't ended, I can't compute the total return for the month of August, so I have to use the end of July. And I pulled the prices from Yahoo, and I have the price every single month for the S&P 500 and every single price for McDonald's. From this, I've computed the return for the S&P 500 over each month. And let me just make sure I didn't screw this up. I went from 31 to 32.7, and I have a positive number, so that's right. Okay, I did that right. And let's see, for McDonald's went from 184 to 194, and I have a 5% return. In the previous month, it went from 185 to 184, so I have a negative return. And the market was up that month, and McDonald's was down. Okay, so now I need to run a regression. So what I'm going to do is I'm going to put my cursor here. I'm going to go to data. I'm going to go to data analysis. I've installed the regression pack. So let's click regression, and that's going to open up the regression box. And my Y range. Okay, let me think about this. So what I'm trying to explain is McDonald's. And so I'm going to enter in column F as my Y range. And what I'm using to explain this is going to be the S&P 500, the market. And I do have labels in my data. In addition, I want my output to be in this cell right here. I'm going to click OK, and it's going to run the regression for me. And I'm just going to make that a little bigger, and I'm going to just take a couple of these values down to 4 decimal points, and we're going to look at a couple of different things. So the first thing we're going to look at is the R squared. And the R squared, this is the portion of variation of McDonald's stock return that is explained by the market's variation. And we'll later on make sure we understand the difference between the R squared and the beta. Down here, I have my actual coefficients. And so these are the values that I've computed. Intercept, this is my alpha. And since I have only a single variable, this is going to be the beta for that single variable. It's going to be the beta for the S&P 500. And so I get a beta of 0.6437. For now, we're going to look at the p-values. And I can look at the p-values for these two. And I can see that the p-value for the beta is 0. The way to interpret the p-value is this. And again, we'll get back to this in a lot more detail when we do the chapter 8 statistics stuff. But the way to think about this is, how likely am I to observe this value of 0.64 if it really is 0? The null hypothesis is there is no relationship between the stock and the market. And if there is no relationship, then the beta is 0. And so the way to interpret the p-value is, how likely am I to observe this 0.64 if the relationship is really 0? And the answer is there's a 0% chance. Now this is the alpha. Now remember that this is a monthly number because we use monthly data. So if I multiply it by 12 and then take a percent, I can see that McDonald's over this 5-year period actually earned a risk-adjusted return of about 11% per year. That's a big number, a risk-adjusted excess return. So after compensating for the risk, it still earned more than it should have based on the risk, and I have a positive alpha. Now the question is this statistically significantly different from 0? And that's a good question. We will, just as an arbitrary number in this class, we'll use a 5% level of confidence. And so since this is 0.1, it's 10%. There's a 10% chance of observing this if it really is 0. So therefore, I can't be confident at the 95% confidence level. I can only be confident at the 90% confidence level. But this is how I would interpret that number. And here I have a chart. And what I've done is I've just graphed each of these 60 dots, and I've created my line, and all of the error terms, which aren't displayed here, would be lines between the dot and the line. This is the best line. This line is best because there's no other line I could draw that would have a shorter distance between each of the dots and the line. And note that the line has a slope of, well, 0.6437, and it has an intercept of about 1% on a monthly basis. So we've run our regression. We have that the beta for McDonald's over this time period is 0.64, and the alpha is 0.0093. We are more than 99% confident in the beta. We're 90% confident in the alpha.